Welcome back. Let's finish up finding the zeros of a polynomial function. So I went ahead and copied this on the bottom. So let's take a look at this one. How many zeros should a polynomial have? So the first thing, should have 5 zeros. Okay. All right, number 2, let's do our P over Q. Use the rational zero theorem. P is 36. So what times what is 36? 1 times 36. Let me write it down here on the side. 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. 6 times 6. So it's 1, 2, 3, 4, 6, 9, 12, 18, 36, 18, 36. All right. Over. My Q, 1 times 2. Okay, so when I do my P over Q, all right, all the integers over 1. All right, let's do the 1 over 2 is 1/2. 2 over 2 is 1, got it. 3 over 2 is 3/2. 4 over 1, 4 over 2, got it. 6 over 1, 6 over 2 is 6 and 3, got it. 9 over 1, 9 over 2, I don't have. 12 over 1, 12 over 2, got it. 18 over 1, 18. All right, so that's it. So this are the positive and negative, P over Q. Number 3, what's my graph should look like? About. My degree is 5. Leading coefficient A sub n is positive. So this is the R power. So which scenario would it be? Leading coefficient positive, degree is odd. So there'll be scribble, scribble, scribble. Right side goes up, left side goes down. So it will look something like that. So let's graph it and we can answer those questions. So let me turn on my calculator real quick. X to the 5th, 7x to the 4th, 20x to the 3rd. Ooh, there's a lot of numbers. 36x plus 36. Okay. All right, let's see how many times. Let's see what we got here. 1. Oh. So to turn it across. Let's go look. Looks like it's about 2, right? I know that's a cross. You know what? Let's do -1 to 3. How about that? Let's look. -1 to 3. I think that's about what I'm seeing here. Oh, there's a cross. And there is a turn. Okay. Okay, so okay. So cross and a turn. So once that goes up, it's probably going to keep on going up because my graph will look something like this part. Okay, so, all right. Let's answer our questions. How many times does the graph cross over the x-axis, if there's any? Do you actually cross it 1 time? So, for B, what can the multiplicity be for that one? Oh, hold on a minute now. How many times did it turn? It turned 1 time too. So a turn got to be multiplicity 2 already. Okay. It cannot be. So, gotta be careful now. It can be 2. If the cross is 1 time, if the multiplicity of the cross 1 time is 1, then 2 plus 1 is 3. So the remaining 2 zeros got to be non-real because I don't see them. But I don't know. I don't know for sure because we still got to think about it for a little bit. Or if this one-time cross has a multiplicity of 3, then 3 and that 2 together is 5, so I'm good. Okay. So if it's a 4, if the multiplicity in the term is a 4, then 4 plus 1 will be the 5, so that's good. But at least, these are what it can be. Okay, so it makes sense what it can be, but at least when we actually go through synthetic division, we got to at least assume the 0 that cross over one time has multiplicity of 1. The one term multiplicity is at least 2, so I got to use that 0 twice. Okay, so all right, let's find the zeros. So let's go to the table. Let's see what we got. Oh, the one on the right side, the one that turned was a positive. Oh, that's 2, 0. So I got 1. So x equal to 2, that's the one that turned. Okay. The other one is negative. So check it out. When x equal to 0, y value is positive. Or when x equal to -1, the y value is negative. So by the intermediate value theorem, there's actually a 0 in between. So which one of these fraction ones, the negative fraction one, actually would be between will actually be between 0 and -1. It got to be the negative half because -3/2, -9/2 is actually going to be -1.5 and -4.5. So the only possible ones I'm going to check is the negative half. So second calc, use the number 1 value and type in -1/2, and that will say y is equal to 0. So x equal to -half, that's the one that actually crosses. So if I'm assuming the multiplicity is 1 and 2, then the remaining 2 0 got to be non-real. Okay. So let's go through the division process and then see. All right. So let's do our synthetic division, number 5. Okay. I got to do, in order to go down to a square, x squared, I got to do the synthetic division 3 times, which makes sense. Turn is 1 time. I'm going to use 2 1 time, but I'm going to use the negative. I'm going to use -half 1 time. The one that turned, the 0 that turned in a multiplicity is at least 2. So I'm going to use 2 twice. So I'm going to use 2 first, twice, because these are a lot of big numbers. So to make it easier for me, I'm going to use the easy number first. 2, -7, 22, -59, 36, 36. All right, let's use 2 first. Okay, bring it down. That's 4. That's -3. That's -6. 22 minus 6, I think, is what? 16? That's 32. That's 27. Is that right? Did I do it right? 22. Make sure to copy it down right. 59, 36, 36. 5, 4, 3, 2, 1, 0. Yep. 27, 34. Excuse me. 54. 36 minus 54 is -18. 2 times -18 will be -36. Remainder is 0. Okay, so this is 2x to the 4th power right now. So since my 0, 2 has even multiplicity, I'm assuming it's going to 2 right now, so I can use that 0 twice. So bring down the 2, multiply, that's 1, that's 2, that's 18. 36 is going to be 9. So 2 times 9 is positive 18. Remainder is 0. So this is now 2x to the 3rd. So let me use that -half that just 1 time. Bring down the 2. -half times 2 is -1. If you add them up, this is 0. -half times 0 is 0. Add them up is 18. -half times 18 is actually -9. So add them up, the remainder will be 0. So now this 2 is actually 2x squared plus 18. So the quadratic equation I'm going to solve is 2x squared plus 18 equal to 0. All right, so if I divide every term by 2 or move this over divided by 2, that should be x squared plus 9 equal to 0, which is not a difference of square. So when I move my positive 9 over, that's actually going to give me x squared equal to negative 9. So when I use my square root property, okay, to solve for x, my answer is actually, my remaining 2 0 is actually positive and negative 3i. All right, so the other 2 zeros are actually the non-real zeros. So my multiplicity is actually 2 at x equal to 2 and 1 when x equal to negative half. So let me just write it down. Okay, so what are my zeros? My zeros are 2, negative half, right? And negative 3i and positive 3i. So why there's only 1, 2? Because the multiplicity is actually what? Even. Okay, so 2 plus 1 plus 1 plus 1 give me 5, x to the 5th power. Okay. All right, let's try another one. Okay. All right, this is 5th power again. Is this a 5th power? Yep, this is also another 5th power. So maybe the two problems are similar. So how many zeros should I have? It should have 5 zeros. All right, number 2, let's do the P over Q thing, 72. 4 is 1 times 4 and 2 times 2. All right, 72. 1 times 72. Oops. 2 times 30, 36. 3 times 124. All right, 3 times 4. 4 times 18. 72 divided by 4. 18, yeah. 5, 6. 6 times 12. 8 times 9. Okay, and that's it. Oh, that's a lot of zero. That's a lot of numbers here. 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. All right, so all these integer over 1 is 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, and 72. Let's count the fraction ones. 1 over 2 is a half. 1 over 4 is 1/4. All right. 2 over 1 is 2. 2 over 2 is 1. 2 over 4 is a half. Got it. 3 over 1. 3 over 2. I don't have 3 over 2. 3 over 4. I don't have. All right. 4 over 1. 4 over 2 is 2. 4 over 4 is 1. 6 over 1. 6 over 2 is 3. 6 over 4 is actually 3 over 2. Same thing. All right. 8 over 4 is 2. So I already got it. 9 over 2. I don't have 9 over 2. And 9 over 4. All right. 12, 6, 3. 18, 9, and what's 18 over 4? If I reduce it by 2, that'll be 9 over 2 again. So I already got it. All right, 24 over 2 is 12, 6, that's 9, 72 over 4. 72 divided by 4 is 18. Yeah, I already got it. So this is it. This is all of them. All right. All right, what should my graph look like? I think this is the same as the previous one. Degree is odd. Leading coefficient is positive, which is, so there'll be a scribble, scribble, scribble. Right side goes up, left side goes down. All right. Oof. 4x to the 5th minus plus 32 x to the 4th plus 63 x to the 3rd minus 141x plus 72. Okay. Oh, goodness. Whoa, there's too many little things going on. Okay, wait. 1, 2, 3, 4. -4 to +2. -4 to +2. Let me see what's going on here. Let me do +3 just in case. All right, that's a cross, a turn, cross, turn, cross, cross. 1, 2, 3, 4. Hold on a minute. That turn right there, got even multiplicity. So if that's 2, if that multiplicity is 2, 2, 3, 4, 5. That's 5 right there. All right, so how many times did I see cross? 3 times. What can the possible multiplicity be? Gotta be odd 1. Gotta be 1. It cannot be 1 or 3 because I'm crossing 3 times. Each one gotta be 1. All right, how many times did I see it turn? 1 time. And that multiplicity gotta be 2. All right. So let's see. Which one is it really? All right, let's go to my table. All right, I got -3. Go put one negative. Okay, -3. Oh man, there's a 1 in between 0 and 1. Right? Positive y, negative y, there's 1 in between. Oh man. Hold on a minute now. I am confused. Right? Hold on a minute. There's 1 between 0 and 1. So the only thing I got between 0 and 1 as far as fraction wise is 1/2 or 1/4. So let's go to second kill. Let me do a half first. 1/2 is right there. Okay. So the 1/2 is actually a cross, which is going to be multiplicity 1. Let me just do second cal and put my -3 in here so I can see where is it. Okay, so the turn is at -3. So I know that multiplicity is 2. This multiplicity got to be 1. So what's the other 2? Okay, so if this cross is at half, this is where 1 is. The next one is actually going to be a little bit bigger than 1 and 2. So if I go to my table and look between 1 and 2, okay, if I look between 1 and 2, the y value does change. So between 1 and 2, the only possible scenario is 3/2. Maybe 9/4. Let's check. 3/2 and 9/4 on the positive side. 3/2, right? Nope. 9/4. Please be 9/4. Nope. Darn it. Okay, if this is -3, then this is somewhere between, if this is -3 where it turns, then the next one is -4. So look for anything between -3 and -4. -3 and -4. There's a 0 in between. -3 and -4. 9/2? -9/2. -9/2. It's about -4 point something. Nah. Let me get my windows up. -5 to 3. All right. So let's try again. -9/4. Nope. -9/2. Nope. Crap. Okay, I'm looking at the two zeros. Okay, it crossed over the x-axis, but I cannot find from the table, or I cannot find from the second count. So what does that tell me? It tells me that it's going to be an irrational zeros, because irrational zeros are real zeros. Real zeros, you can see them on the graphing calculator where it crosses over the x-axis. So right now I am anticipating that the last two zeros going to be irrational zeros. All right, so let's go through the synthetic division. So I'm going to do the -3. Since it turned at -3, I can use it twice. 4, 32, 63, -46, -141, and 72. All right, -12, add them up is 20. -60, that's a 3. That's a -9. -55. 3 times 55 is going to be positive 165. 165 minus 141, 24. So -3 times 24 is -72. That's how my remainder becomes 0. All right, let me use -3 one more time since I got even multiplicity. So that will be -12. That will be 8. -24. -21. Negative. Whoa. 4. -12. 8. That's positive. Oh, never mind. That's positive 63. So 63 minus 55. 8. Positive 8. That's -24. Remainder is 0. All right, so this 4 now becomes 4x to the third, right? The first 4 was 4x to the fifth, 4x to the fourth, 4x to the third. So now one more. That's why I need to do one more 0, which is in a half. Half of 4 is 2. Add them up is 10. Half of 10 is 5. Add them up is 16. -16. Half of that is -8. Remainder is 0. So now this is actually 4x to the second power plus 10x minus 16. All right, so the quadratic equation I'm going to solve is going to be right here. Now, since I kind of know the other two zeros is going to be irrational, I'm going to go ahead and factor out 4, okay? So have a little bit of, oh no, can't factor out 4. Let's do 2. Having a little bit smaller leading coefficient. Have a little bit smaller coefficient. This cannot be factored. All right, so x equal to -b plus minus square root of my b squared minus 4 times my a times my c, whole thing over, 2 times my a, which is 2. Since I'm factoring the 4, my coefficient is a little bit smaller. All right, let's see what's inside the square root. 5 squared minus 4 times 2 times -8. 89. Aha, we did this problem earlier. So that's going to be -5 plus minus. We actually did a problem earlier. Earlier means we did this problem in other video before. 89 over 4. Voila. That's the other two irrational zeros. So let me write down what are my zeros. My zeros are, okay, -3, a half, and -5 plus minus, -5 minus square root of 89 over 4. And my last one, -5 plus square root of 89 over 4. Voila. Okay. So using a lot of different theorems, techniques, and different concepts to actually help us to find the zeros. All right. So that will conclude this video. And this will also conclude us finding the zeros of polynomial function as well. Okay, thank you for watching.